Hello everyone. Today let's solve the problem minimal string. So this was asked in educational code forces around 19 basically, right? So you can just go through the question. I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given a string S. Just give me a second here. So we have been given a string S. We can either perform two operations. So we are given a string S. We can perform two operations basically, right? What are the two operations? Mainly, one is we can move the first character of S to the stack T. One is we can move the first character. Just give me a second. Let let me come to the example part here. So yeah, here you can clearly see, right? So this is string S basically. This is string S. We can move the first character of S to the stack T, in this case C, right? Or we can pop the last character from stack T to the resulting string U, or you can this one, pop the last character from the stack T to the resulting string U. These are the two conditions that we can do, right? And what is our main goal? Our main goal is to empty both S and T. So our main goal is to empty both S and T and form U. S and T and form U, right? So we can uh, our main goal is to empty both S and T, and we have to form U to be lexicographically smallest possible. So we have to empty both S and T and form the string U to be lexicographically smallest possible. And this is the main thing. Basically, what we need to do, we need to empty both S and T and form U to be lexicographically smallest possible. So this is very important. Lexicographically smallest possible. Right. So this is very important part. Right. So I hope the question part is completely clear. I hope the question part is completely clear. Here you can clearly see we have CAB, and we either we can move the first character of S to stack T, or we can pop the last character from stack T to the resulting string U. Here in this case, after doing these operations, after doing either of these operations, we will get the output ABC, right? We will get the output ABC. Next, let's go with the input ACDB. Accordingly, with the lexicographically, this one smallest string that is possible, the output will be ABDC. Quite obviously, the output will be ABDC, right? So I hope the question part is completely clear. Next, what shall we do? Let's discuss the this one approach first, right? Followed by the complexities, and then let's write the code. Initially, let's discuss the approach first. So let's consider first example that they have given in the question, so that we have already discussed this one, so that it will be easier for us to understand the approach, right? So the input is CAB, and the output that we need to get here is ABC. Accordingly, with the lexicographically smallest element, means we have to either empty both S and T and form U. So this is nothing but S here. So we can either, the goal is to empty both S and T and form U to be lexicographically smallest that is possible, right? So let's see the same thing. So the output we need to get here as ABC. So one thing that we need to keep in mind here is we will be going with a stack with greedy approach, right? So mainly we'll be going with a, so this problem is basically designed to be solved with a stack, right? So this problem is designed to be solved with a stack. So let's go with a stack with greedy approach, right? So here in this case, let's go with a step-by-step explanation. So first what we will do, we'll start s equals this one, the same input we are considering, right? So we'll start with s equals CAB, and T initially this one, T and U will be initially empty string, right? T and U will be initially empty string. So first step is we will push C. We'll be considering the first we'll be considering the first letter. So in the question what they have given, so we can either move the first character of S to the stack T, or we can pop the last character from stack T to the resulting string U they have given. So here in this case we are going with the first condition. We are moving the first character of S to the stack T. So nothing but here we will be moving, will be pushing C. Nothing but now T will be quite obviously C. right? Next smallest in suffix is nothing but a. We have already considered c. Next smallest in suffix is nothing but a. Now this will be t dot top equals c greater than c, quite obviously greater than a, right? So accordingly with the ASCII, so what we will do, and we have to find the lexicographically smallest possible, right? So we will wait, c is quite obviously greater than a, stack t dot top here, nothing but stack t dot top here, it is greater, it is equal to c, which is greater than a. So in this case we will wait, right? So let's go with the second step. Let's push a. Same thing we are doing now. So we are moving the first character of S to the stack T. We have already moved that one. C. Now we have to consider A. We'll push A. Now T will be CA. We are considering two characters. Now T will be CA. So now stack nothing but T dot top, or the stack dot top will be A, that is less than or equal to B. Right? Less than or equal to B. Now what we will do? We will pop A. Now we will pop A, nothing but u will be a. You consider, say, after popping a, you will consider a. What are all the elements that we pop, we will be saving that one in the a basically, right? So now t dot top is nothing but c less than or equal to b. So this is false, right? C is not less than or equal to b. In this case this is false, so again we will wait. Here in this case we will wait. So let's move on with the step 3. Same this one, same operations will continue, just that we are left with the last character in the string s. So we will push b, the last character. We have c a we have, right? So we are done with c and a. Now we have the character b left, so we will push b. T consists of cb. We have already popped a here, right? So a less than or equal to b will compare, yes we can. So in this case we will pop a. So u contains the thing that the character that has been popped, so u equals a. Here in this case, next step, we'll compare c less than or equal to b, because stack contains c. C we are comparing with this one, right? B basically. A and c we are comparing with b. C less than or equal to b, false. So we'll wait. We are going with a lexicographically smallest possible this one characters, right? This one word basically. Here in this case we will push b. Now t equals cb. First what we'll do, we'll consider t dot top, nothing but stack dot top equals b, right? Minimum suffix is completely over. We are done with the minimum suffix, so we will pop all. So we will pop all. So now the this one, whatever we pop basically, here in this case this will be stored in the u, right? So we have already popped this one a. So accordingly with the lexicographically smallest this one character, this one string that is possible, will we have popped c and b because minimum suffix is already over. So we will be this one, the popped elements will be stored in the lexicographically lexico graphical order. Basically it will be bc, right? It will be bc. We will be saving bc after a, as we have popped bc other elements. In this step we are popping a, in this step we are popping bc, right? So we will save all the characters in this one u. Now u consists of abc, right? Now u consists of abc, right? So the final output that we got here as abc, which is equivalent to the output here they have given for the first example, right? Abc. So the output that we got is ABC, which is equivalent to the output that they have given for the example one. So quite obviously, the approach works absolutely correct. So now, as we are completely familiar with the approach, let's discuss the complexities very quickly. So what will be the time complexity here? The overall time complexity would be quite obviously big of n. So why the time complexity would be big of n here? The time complexity would be big of n because every character is pushed and popped exactly once. So accordingly with the approach, you saw the same thing, right? Every character is pushed and popped exactly once, so the time complexity would be quite obviously big of n. And what would be the space complexity here? The space complexity would be big of n as well, because we are considering stack t, and we will be going with the string builder and minimum suffix. So min suffix, so here in this case I said min suffix is over, right? So we will be going with the minimum suffix keyword basically, right? So here we'll be making use of the stack t. We have seen that one in the approach. We will be making use of the stack T and string builder U. All the popped elements will be saved in the string builder U, and we'll be making use of the min suffix as well. So we'll be making use of the min suffix keyword or the variable, right? Which are all are of the linear space. So space complexity would be quite obviously big of n as well. So the time complexity and the space complexity for the code that we'll be writing will be big of n, right? So I hope the complexities part is completely clear. Now we are done with the this one, complexities. Basically now we are completely familiar with the complexities as well as the approach. We are good to write the code now. Let's start writing the code. So let's start writing the code. So I'll just come here. First step, what we'll do, let's import the input output package as well as utility package, right? So I'll just go with import Java input output. So this is fine. Next step, import java.util.star. This is fine. So next step, let's go with the class here. So I'll just go with public class. This one will be main. So within this, let me type main here. So this is fine. Let me remove this one. And let's make use of here throws input output exception, or else we'll get the error. So let's go with the input output exception. This is fine. So within the class, first what we'll do, we'll be making use of the input reader, fast input reader and the fast output writer. So that is the reason we have imported the package, this one, input output package, right? So let's do one thing. Let's make use of buffered reader. So let's go with a variable name br here. So this will be new buffered reader, new this will be input stream reader, this will be system.in. So this is fine. Next step here would be we'll be making use of the print writer as well. So print writer out, this one will be new print writer system dot out. So this is fine. So after this step, we have to read the input string. So I'll just go with string. The variable name is, will assign this one to buffered reader br we have considered, right? Variable name. So we have to read the input string, right? So I'll just be making use of read line here. This is fine. And also we have to go with the length of the string. We need to consider the length of the string, right? So I'll just go with int n equals s dot length. So this is fine. Next, as we have already discussed that we'll be going with a stack with a greedy approach, right? So let's make use of the stack, nothing but we'll be going with the stack T to we have to simulate the stack moves, right? So we'll be considering the stack T here. So I'll just go with stack. So this will be stack of character T equals new stack. So I hope this is fine. Next part is we will be what can I say here? Let's go with the string builder. So we have already discussed that we'll be making use of the stack, string builder, and min suffix, right? So while discussing the space complexity as well as the approach, right? Let's consider the string builder by just for the sake of efficient string appending. Nothing but whatever we pop, that we are saving in the result u, right? Or the string u. So let me go with string builder here. U be new string builder. So this is fine. So the next step is we need to pre-compute the minimum character in the suffix, that is starting at each index. This we have seen, this we have already seen this one in the what do you call approach. So let me do one thing, int array. So we'll be making use of the min suffix variable name. We have already discussed this one. So this will be new int of n within the array. So last character in the suffix min will be at the last position. So we can just articulate in the form of code in this way. So I'll just go with min suffix of n minus 1. So this one, let me assign this one to char at, so this one char at n minus 1. So this is fine. So let's fill the minimum suffix from right to left. Let's fill the minimum suffix from right to left. So we'll be going with the reverse iteration. So this will be int n equals, sorry, int, we have to assign this one to something, right? So I'll be making use of iteration, reverse iteration, right? So this one will be I greater than or equal to 0, I minus minus. So within the for loop, at each position we have to store the smaller of current and next minimum. So here I can just go with I can just we can just articulate the same thing in the form of code in this way. So at each position we have to store the smaller of the current or the next minimum. So iterated value of the min suffix, we can assign this one. We need the minimum, right? So I'll just go with math.min of s dot. I'll just make use of caret here, caret I, and also we need to consider min suffix I plus 1, because we need to store the smaller of current or the next minimum. Smaller of current is nothing but this one, next minimum this one, min suffix of I plus 1. So I hope this part is completely clear. Let me come out of this one entirely. Loop, for loop I was speaking of basically. Now let's consider the pointer to characters in the S. So I'll just go with initialization. So I'll just initialize I to 0. So this is fine. So the next step is we need to simulate the process of moving characters, nothing but from S to T to U, right? S to T, then T to U, right? So T, accordingly with the conditions, two conditions that I have read in the question. So whatever the will either consider the first character. In our case, in the example, we considered the first character and we pushed to the stack T, right? Then accordingly with the condition, we popped the elements, right? So we popped the elements and then we were saving in the U. That's what we need to simulate the process of moving characters from S to T to U. So let's write the simple while loop here, because I has to be always less than n, right? So that is the reason we'll be making use of the while loop here. So while I less than n, what we'll do, we have to move the character from S to stack T. So this will be T dot push here, S dot char at, so this one I. So this is fine. Next step is we need to pop from T to U, right? So we have discussed this one multiple times. We need to pop from T to U if the top of T is less than or equal to min, right? So how can we articulate the same thing in the form of code here? So let me write this one very quickly. While not of T dot is empty, let's go with the operation is empty. Let's make use of the operation is empty that the stack provides basically. So and let's go with I equals n minus 1. This is fine. Or let's go with peak operation. Let's make use of the peak operation as well. Less than or equal to min suffix of I plus 1. This is fine. So within the while loop, what we'll do, we'll move the character from T to U. Nothing but we have to append, right? So I'll just go with U dot append. Within the function, I'll just go with a pop, because we have to move to the this one. We have to move the character from T to U, right? So we'll be making use of the pop quite obviously. Yeah, this is fine. Accordingly with the approach, we are just articulating the same thing that we have discussed in the approach in the form of code. We are just articulating the same this thing in the form of code, the same thing that we have discussed in the approach. So next we have to move to the next character in S. After considering that particular character, we have to move to the next character in S, right? So for that, let's increment the I. So this is easy. So let me come out of this one entirely. So what will be the next step? After S is empty, we have to pop remaining characters from T to U as well. So let's write the simple while loop here. So while T shouldn't be empty, while T, let's make use of the is empty, this one, what do you call, operation that the stack provides basically, is empty. Then again, So I'll just go with u dot append t dot pop. The same operations here. Somewhere we performed this one, right? This one. But here in this case, only after S is empty, we are popping remaining characters from T to U. So here this will be same. These two things. This one, right? This is fine. I'll just come out of the while loop entirely. Final step is we have to go with the input output operations, right? We have to output the final string U, nothing but in this case, uh, out dot. Let's make use of the println. So let me type this one. So this is fine. This will be U dot to string. This is fine, I think, right? So the next step here would be we have to flush. So this will be out dot flush, right? So this is it for the code. This is it for the code. I hope the code works. Let's see. Let's do one thing. Let me copy this one input, and for this input we have to get the output ABC. Let's check whether the code works correctly or not. Let me run the code. We have the, so here why I have given dot here in the line number 28, right? So let me remove this dot. So this has to be, just give me a second, where it is. So here this has to be T, right? T dot is empty. So I have not given T at all here. So let me run this one again. So yeah, now we are getting the output, correct output, ABC. So here I missed T basically. So that is the reason we were getting the error. So let's check with the second input here. We need to get the output ABDC, right? So let me copy here. Yeah, we are getting the output ADBC, right? So our code works absolutely correct. So let me do one thing. Let me copy the code. So let me paste it over here, right? So before submitting, let me paste the signature starter template, right? So I hope this works for all the test cases. Let's see. Let's submit. So let's wait for some time. Let's see whether this works or not. So here you can clearly see here running on test case 150. Yeah. Here you can clearly see the code got accepted. Means whatever the code that we wrote works absolutely correct, right? So I hope the solution part is completely clear, right? I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.